Hi. Okay, so I'm going to talk through some of the documentation of this Arduino project. I didn't include all of this documentation in the splashier video because I think it kind of drags things down, but it's pretty interesting from a technical perspective, or at least I think it is, what I did and why I did it. So basically what started this was I wanted to do a test of the human visual system. I wanted to find out what the Nyquist frequency was. Video frame rates are about 30 hertz. And I thought, well, I could play around with this persistence of vision phenomena where you're scrolling through and updating lots of little LEDs fast enough that it looks like a continuous image. It didn't work out as well as I wanted to for that purpose, but it did end up being a pretty cool project where I play around with the Wii Nunchuck and make a cool little gizmo to show some of my friends. So if I look here at some documentation, I tried to do this test to find out what's the Nyquist of the human visual system, and this chart takes a little bit of looking at, but basically I found that the Nyquist frequency was probably somewhere around 10 hertz. The Arduino timing files were a little weird. If you tell it to flash for 1 microsecond, it's not exactly 1 microsecond, and so I had to go and kind of make a kludgy solution to get all that put together. But it worked pretty well, and like I said, the Nyquist frequency is somewhere around 10 hertz. Here's the schematic of the printed circuit board that I designed. I used Express PCB because it's easy and cheap. It has some limitations, but overall it's pretty good for hobby projects like this. I'm going to step through some of the aspects of the design. Here you can see there's a serial shift register for the X direction and also a serial shift register for the Y direction. And what happens is the Arduino will clock in a data word, an 8-bit data word, and each of the registers, the X and Y direction, will have one and only one bit set high and all the other bits set low, and that fires one of the LEDs. And then for the next frame I update it with a new data word and then apply it to the LEDs. So how does it work? Well, for the X direction, the data word comes in and it spills out onto the lines. There's seven lines, well, 8 lines rather, because it's 8-bit, and I zero index, so it's from 0 to 7. And then here's the LED array, so there's nothing limiting that side. For the Y direction, you come out through some current limiting resistors here, 330 ohm, just to keep things from overheating and running away. It comes out to some opto-isolators, and the opto-isolators are here just because it's easier to set things between a 0 and 1 on the Y direction using the opto-isolators rather than directly sending it through the serial shift register. Part of that was that I was concerned, could the serial shift register sink as much current or source as much current as was needed, and the opto-isolators definitely could, so I just included them for a little extra buffering in the system. You have the Y serial shift register comes out, and then this is the port where the Arduino pins come in. So it's a pretty simple design. A couple of other features. There's an extra jumper where VDD and ground come onto the board. Let's see. There's some jumpers here on the Y direction, and some others down here on the X direction for troubleshooting. Now, if you go over to the layout, here it was a little tricky to try to fit this into the allowed design space from Express PCB, and part of that was there's no auto routing. If I did it over again, I might consider not using Express PCB because it was a pain to try to figure out how to fit all this stuff in, but it's a basic board and it works pretty well. It's a 2-layer board, top metal, bottom metal, and the green here is showing bottom metal connections, the red is showing top metal connections. This was about $100 shipped from Express PCB, which was pretty nice. Let me go through some of the stuff here. So let's just follow the same train in. So here's the X in. There's a header here where the leads come in from the Arduino. The serial shift register comes out. There's the X jumper, it spills out to the LED array. and then comes back around. Here's the current limiting resistors, the Y jumper for breakout points, some opto isolators like I described in the schematic, the header that feeds data to the serial shift register, and that's it. It's pretty simple. I didn't include any bypass capacitors or really any consideration at all for high frequency because I'm only operating up to a megahertz tops, and I didn't think it was worth the effort to consider those things. Here's the code I wrote from scratch for updating the array and taking care of all of the handling with it. There are only 3 pins per dimension, Y data, Y clock, and Y latch. Y data is obvious, this will be the 8-bit data word that spills out to the serial shift register. The clock is what I use to clock the data word into the serial shift register, and the latch is what latches it out onto the lines. There's the same for the X direction. Here the LED state, I just did a high and low to make it easier for data handling. I set up the pins and have a serial monitor here so that I can monitor some details in real time as I go through. And then the loop starts. So we start by instantiating an 8x8 array, which will light up a single pixel within that array for each frame. And then I wrote a subroutine where I zeroed the array, set all the pixels to 0. So I start at a known state. Here's some code I use to check for Nyquist frequency of the human visual system. Like I said, that didn't work out as well as I thought it would, or that I'd hoped it would. So it didn't really play much of a part in the final implementation. I set up some delays and image delays and strobe delays. The strobe delays and strobe loops, this is for if you want a single LED to be firing at a time in a distinct way so you can actually see the LED scrolling through, and then the images if you want to have persistence of vision, you want it to dwell, and this would be something longer than the 10 Hertz frame rate. I don't know exactly what it was, but it is longer than that. Then there are 3 modes, maybe several more, not just 3. So mode 0, this is where I just strobe through all the pixels, lighting one up at a time, and the human can distinctly see one of them lighting up at a time. The next one is a image. It uses persistent vision, makes that X shape that you saw in the video, and I'll show those videos at the end of this one of scrolling through the array. The next mode makes a smiley face, pretty simple, and then I guess I didn't. Oh, here I address a single pixel, and then the last ones. These are for scrolling X shapes that you saw at the beginning and end of the video. I'm sorry, at the end of the video. And I'll comment a little bit more about them in a minute. Here's mode 0, just the strobing through all pixels. You can see it's very simple. It's just a for loop that iterates through the entire thing. For what's the next one? The X shape, I just set certain pixels to be 1, and the rest are 0, and then it's a for loop that goes through and updates. This one's, I think, the smiley face, and it's pretty much the same. All this is pretty basic. The only place where it gets a little tricky are these scrolling X's. I had to fiddle around with the for loops to try to get it to wrap around from one side to the other side, and it was a little kludgy when I did it, but it worked out okay in the end. I'll just kind of scroll down through here so you can see what else there is. Here's the mode 5. It's one of those scrolling X's. I'll dwell here for a minute in case you want to see the code. I'll dwell here. You can see there are quite a few for loops there to make it all work. Here's the 0 array function. It's very simple. Just I broke it out as a separate module so that I can call it when I need it. Here's a max array function, which is the opposite, the inverse of that. It just sets all the pixels to 1. And then here's the display pixels routine. Just scroll through here. Okay, anyways, I'm going to stop this at this point. You got the main idea. The second part of the project was to implement the Wii Nunchuck, which I thought would be a fun little tweak, and it was. The Wii Nunchuck is pretty simple. It's just a 4-terminal device. It has a power pin, a ground pin, a clock in pin, and a data out pin. And there's 6 pieces of data that come on the output. There's the joystick XY, the accelerometer XYZ, and then the push buttons. I'm only going to use the accelerometer X and Y. I'm not using the Z data. As opposed to the LED work, I borrowed code extensively here. And let me give some credit for that. This is the website that I got a lot of it from, www.growdown.com, growdown.com. And it worked out really well. You need 2 files here. There has to be this PDE file, the normal Arduino file, and then there's this Wii Nunchuck library.h, which has to be open at the same time as the Arduino file. So let's see, I'll walk through here. It includes this math library and a few other things, define the max angle, min angle, and let me see what I need to go over here, the little tweaks I did for my implementation. Here's the, like I said, Y data, Y clock, and Y latch. That's used again here because I had to interface it with my LED array, and here's the instantiation of the pixels. I used basically that mode where I was just lighting up 1 pixel, and that worked fine for implementing it with the Arduino. This is an interesting part. So when I read the accelerometer information from the Wii Nunchuck, it gives a reading, but I had to constrain that between some values to make sure that it mapped to something useful for the LED array. And these are the lines of codes that cover that. Otherwise, it's pretty simple. Okay, so I'm going to go on with the documentation here, just showing the X's smiley face, scrolling X, and the reverse scrolling X. So what would I do? And here's the Wii Nunchuck scrolling around, tilting back and forth and lighting up an LED. What would I do if I was doing this project over again? Well, one thing I would do is try to find some way to increase the dwell time per pixel so the light output is brighter. Maybe I would use a different multiplexing scheme instead of a serial shift register, maybe some other kind of tool. Basically, wanted to get the duty cycle up, because the reason they're dim is that the duty cycle is rather low for the persistence of vision phenomenon to work. Alternatively, I could use brighter LEDs, and they are made. They just wouldn't fit on this printed circuit board. Not in the current implementation. I have to redesign it. Or I might use higher drive currents, though I don't know if that would work very well. But in any case, I've been overall pretty happy with the project. I learned a lot from it and have a good mental toolkit for future projects. I hope you enjoyed this documentation and all the videos. Please visit my website, ambientelectrons.org, which will be located in the splash screen at the end of this video. And coming to the close, here's the pins coming from the Arduino to the board. There's the Arduino I used, the Arduino Uno. What else? I hand soldered it. This was all done by hand in a lab. And then here's the close. Thank you very much.